Here we are beginning our fourth unit in MCT4C. We're looking at polynomial equations for this unit. It's very tightly tied to our polynomial functions. The difference is we don't have the y equals part of it. We're just looking at replacing that y with 0 and then solving for the value of the variable that will make the equation true. So our goal here today is to focus on just the quadratic equations, which you've had experience in grade 10 and 11 doing. So it really is a review lesson today. Our quadratic equation has an equal sign. That makes it different from just a quadratic expression, and it doesn't have the y, so it's not a function. And it has a degree of 2, of course, because it's quadratic. Now, something I've noticed with my younger grades, they don't know what the word solve actually means. And solve just means find the value of the variable that makes the equation true. So if your variable is x, you want your final line to be x equals, and then whatever value that is. Also, you can do a check, and we often do that as a left side, right side thing. So that's what this LSRS is. Once we find our value at the end, we could always check, sub in the value to the left side of the equation and the right side of the equation and check to see, does that left side actually equal the right side? All right, first example here is solve. I have a very simple quadratic equation. I have x to the exponent of 2 equaling 25. Now, simple enough. I only have x appearing once in the entire question, so I can just isolate for x. I can get that squared undone by doing the opposite, which is square rooting. So when I square root both sides, you have to remember that there's always two answers to that. There's the positive square root of 25 and the negative square root of 25. So there's two answers for this. One is that x is equal to 5 or x equals negative 5. Now if I sub that in for the x back into my original equation, my left side would be 5 squared, which is 25, and that equals the right side. If I use negative 5 times negative 5 is also positive 25. So left side, right side check is pretty straightforward in that one. All right, next example. Again, x appears only once in the entire equation. I can do bedmiss backwards, which is Sam Deb. And I could get rid of any adding and subtracting first, which there isn't any, so I don't have to worry about that. My x is being multiplied by 4, so that would be my next step, or my first step. I'm going to divide both sides by 4 here. And we're going to end up with just an x squared being equal to, and 144 divided by 4 is 36. And then again, to undo that square, we're going to square root both sides. And when I do, there's two answers. There's the positive and the negative answer, and we get x being equal to positive 6 or negative 6. Now you might see in answers, sometimes they write that as x equals, and they just leave that as plus or minus 6. That's acceptable as well. All right, part C, again, x appears only once here, so we can actually do Sam Deb. And I just noticed I spelled Sam Deb wrong. That was supposed to be B at the end. Oh. All right, I'm going to undo the subtracting first by adding 147 to both sides. So we get 3x squared is equal to positive 147. We are then going to divide to undo that multiplication. Divide both sides by 3. And we get x squared is equal to, that goes, 3 goes into there 4 times, carry the 2, that goes in 9, that gives me 49, so x squared is 49. Square root that, I get x equals plus or minus 7. Okay, two answers to that. All right, next one, x also only appears once. Now I've got exponent, and I have something within the brackets, so I have to undo the exponent before brackets. That's what my Sam Deb tells me. So I'm going to square root both sides. I'm going to have plus or minus the square root of 81, which is 9. So we have x minus 4, goodness, x minus 4 being equal to plus or minus 9. Now I'm going to undo the minus 4 by adding 4 to both sides. Did not leave myself enough room for that. We end up with x by itself on this side, and we have plus or minus 9 plus 4. Now we'll never leave it like that. We're going to actually evaluate. So there's two answers again to this. We have the positive 9 plus 4. which gives you x equals 13 as one of your answers. And then the other one would be x equals negative 9 plus 4, which is equal to negative 5. So there's two answers for this, either x equals 13 or x equals negative 5. If we put either one of those in for the x, when I subtract 4 from it and then square that answer, we will get 81 as our answer. The left side will equal the right side. All right, I just noticed I have a typo on my copy, which I'll try and fix on yours before I print it off. I need an equal 0 here. I forgot to do that. It's very similar to a mixture of D and C here, C and D. I'm going to add 242 to both sides, then I'm going to divide by 2, then square root, and then undo the plus 3 by subtracting 3. Why don't you try that and see how you do? Okay, hopefully that makes sense. I added 242 to both sides, divided both sides by 2 here, then I took the square root of both sides, and then I am subtracting 3 from both sides to get my two answers here of x equals 8 and x equals negative 14. So our key idea behind this question number 1 is that if x appears only once in the entire equation, and this is the only time this works with quadratics, then we can isolate just like it's a linear equation. We perform that SAM-DEB. So that's what we're going to type in for our key idea. All right, so our key idea is that if x appears only once in a quadratic equation, we can isolate for the variable. Treat it like it's linear. Do that SAM-DEB. The reverse order of BEDMES undoes the operations. Remember that square rooting both sides will always produce that positive and negative answer. That's the other thing to remember with this method. So don't forget those things. All right, example 2. All of these examples here are not like the previous ones where x appeared only once. You can see that in the first example I have x happening actually twice, x minus 1 and an x plus 2. So in this case I can't isolate. But the really nice thing about this one is that it's in its factored form. And when it's in the factored form, remember we could find the x-intercepts really easily for our functions? Well, it's the same thing, only instead of, like, we've already just got the y equaling 0 anyway. So for our x-intercepts, we always let y equal 0. So really it's the same process that we've done before. We know the product of two things will only ever equal 0 if one of those two things actually is a 0. So my factor here of x minus 1 would have to equal 0. I'm having a little difficulty, technical difficulties. Hold on here a second. Okay, so we have an x minus 1. Either that thing equals 0, which means then add 1 to both sides and we get x equals 1, or we have x plus 2 has to equal 0, which then subtract 2 from both sides, we get x equals negative 2. So that's why we always switch the signs to get the actual x-intercepts from the factored form of a function. All right, part B, our two factors are really 3x and an x minus 9. If we set those equal to 0, 3x equals 0, that really, we can ignore that 3 and it becomes x equals 0. We're just dividing both sides by 3 there. We're going to get an x minus 9 equaling 0, which means x equals 9. We're just adding 9 to both sides. All right, the last one, they're a little bit trickier to find what the x-intercepts are because of the coefficients not being 1s when it comes to the x's, but the process is the same. We're just doing 2x plus 5 equaling 0. I would subtract 5 from both sides. We're going to get 2x equals negative 5. Divide both sides by 2. We're going to get x equals negative 5 over 2, or negative 2.5. This last other part to this, we've got 7x minus 4. That factor could equal 0. 7x equals positive 4 when you add 4 to both sides. Divide both sides by 7. You're going to get x equals 4 over 7. So that one has two answers, the negative 5 halves and the 4 sevenths. So our key idea behind this is if your quadratic is in its factored form, you're just setting each factor equal to 0 and solving the little mini equations. Okay, so I've just typed that in there. When a quadratic equation is in its factored form, set each factor equal to 0 and solve each little mini equation. All right, I'm going to continue this lesson on the next video.